Hello students, welcome to the first lecture on the lecture series on approximation and simplification. So in this lecture what we'll do is we'll learn some basic type of problems that is based on concepts and some types of problems. Okay, so let's start this lecture so that we could get the gist at this topic. Okay, so this is the first lecture on this lecture series and we'll be covering concept and types of problems on approximation and simplification. Okay, so these concepts, okay, that is the concept of approximation and simplification. They involve estimating or rounding of numbers to make the calculation easier and quicker. Okay. So in real world scenarios, what happens is exact calculation may not always be necessary. Sometimes approximate answers are often sufficient. Okay. So let's go for the definition of what approximation. So approximation is what? So approximation is the process of finding a close value of a quantity number, okay, or expression that is easier to work with. Okay. So understand compared with to its exact value. Okay. So what are the properties of approximation? So rounding of numbers. This is one property of approximation. The second property is estimation and the third property is decimal approximation. Okay. So let's discuss the first kind of property, that is rounding of the number. So in approximation we often round off numbers to a certain decimal place or significant figure. Okay. And what is estimation? So estimation is a valuable technique in approximation where we use rough calculations, okay, to get close approximate values. And what is decimal approximation? So for example, root 2 is approximately 1.41, pi is approximately 3.14, etc. Okay. So definition. So simplification. Simplification helps in obtaining concise and clear solutions, making mathematical operations more efficient and understandable. Okay. So let's see the properties of simplification. So order of operations, simplifying fractions, exponent rules, square and cube of numbers. Okay. So order of operations. So simplification follows the BODMAS, that is the brackets, orders, divisions, multiplication, addition and subtraction. Okay. When we are given a lot of algebraic operations, then what is the preference of algebraic operation, that actually which operations need to be done first to get the accurate answer. Okay. So that is what the BODMAS rule was. First go for brackets, then go for orders, then go for division, then go for multiplication, then go for addition, then go for subtraction. That was what BODMAS rule was. Okay. So the second one is a simplifying fractions. Okay. So reduce the fractions to their simplest form by what? By cancelling out the common factor in the numerator and denominator. Okay. So if we are given a fraction that is 3 by 6, let's say, then we know that we can write 3 as 3 into 1 and 6 as 3 into 2. So what we do is we take 3 common or we cancel out 3 in the numerator and denominator. So we can write it as 1 by 2. So this is what simplification of fraction means. Okay. So what is exponent rules? So exponent rule is what? A power m into a power n, where a is the base and m is the power. And here a is the base and n is the power. So multiplying these two, what we are left with is a power m plus n. Okay. Where these numbers are multiplied right here. Here a power m plus n, m and n are added. If we are given as a power m power n, this is equal to a power m into n. So for example, if we took 2 power 3 into what? So let's verify these. So it will be 2 power 3 into 2 power 5, let's say. Okay. So this will be equal to 2 power 3 plus 5. So let's say don't really, okay, agree that these are right. Okay. Just verify them using definitive constant values. Okay. So here we are taking, so it will be 8 into what? 2 power 5 is equal to 32. So this will be equal to 2 power 8, right? 2 power 8. So this is equal to nothing but 256. So this is also equal to 256. So from here, by taking these two examples, we can verify the same for the first case. Let's see for the second case. Okay, let it be 2 power 3 power 4. Okay, so this will be equal to 2 power 3 into 4. Okay, so it will be what? 2048 into 2. It will be 2048 into 2. So this will be 8 power 4, right? because 2 power 3 is equal to what? It is 8, and 8 power 4 is equal to this much amount. It is 4 into 3 is equal to 12. Okay. So a power this is equal to 2048 into 2. So these two are same, so we can verify the second one also. So a power minus m is equal to what? We can write it as 1 by a power m. Okay. So let's see the formula and properties for simplification. So square and cube of numbers. What are square and cube of numbers? So learn the square and cube of common numbers up to a certain range to simplify calculation. Okay. So like 2 square is equal to what? 4, whereas 2 cube is equal to 8, 3 square is equal to 9, 3 cube is equal to 27, 4 square is equal to 16, 4 cube is equal to 64, and 5 square is equal to 25, 5 cube is equal to 125, 6 square is equal to 36, 6 cube is equal to 216. Okay, so it will be what? So like this we should remember up to 20. Okay, so that everything goes smoothly and we could simplify most of the calculations. Okay, so let's see the type of question. So basically there are 9 type of questions. Okay, 9 types that are usually being asked in the examination. So the first type is rounding off and estimation. Okay, the second one is decimal approximation. Third one is simplifying the expressions. Fourth one is fraction simplification. Fifth one is percentage approximation. And how decimal approximation and percentage approximation differ from each other, we'll learn. Okay, we'll learn how they are different. Okay, what kind of significance they possess in real world scenarios. So the sixth one is on approximate calculations, simplification of equations, squaring and cubing, so conversion and approximation. Okay, so there are basically 9 type of questions, okay, that are usually being asked on this topic in various competitive exams. So let's see the first type, that is rounding off and estimation. Okay, so questions where candidates need to round off numbers to a certain decimal place or use estimation techniques to obtain approximate values. Okay, so let's see a problem to get a better view at it. So root over of 15. Okay, so root over 15, so approximate the value of root over of 15 to the nearest whole number. Okay, so approximate the value of root over of 15, so the nearest whole number will be what? 15 is approximately, root over of 15 is approximately equal to what? Root over of 16. So 15 is closer to 16 than to 9. So when we are given a value x, okay, we'll try to know the before values of x and after values of x. Okay, and we try to know which one is closer. Okay, if we take the difference and take the modulus, then what will be the lowest number? So the side possessing the lowest number will go for that value. So in this case we have 15 and we have 9 here, 9, 10, 11, 12, 13, 14, then 15 comes, but after 15 just there 16 comes. Let's try to take what? 21 square root. Okay, so in this case what you will do is you will write 21, 22, 23, 24, 25, right? So this is a perfect square. So you will learn what this will be: 20, 19, 18, 17, then 16. Okay, there is a perfect square. But let's see what is the difference. 1, 2, 3, 4. 1, 2, 3. Okay, so the difference is only 3 here. So this has difference as 3, right? But this has difference as what? 4 as difference. So 16 is actually more distant to 21 than 25. Okay, so that's what we will write. What? 21 is approximately equal to 25. That will be equal to 5. Okay, so you can write this as this one. Okay, so similarly here we have written 15 is root over of 15 is actually kind of approximate to root over of 16. So it will be approximately equal to 4. So square root of 16 is as 4. Okay, so we'll say root over of 15 is actually approximately equal to 4. Let's see the type of questions. So decimal approximation. So problems involving the approximation of square roots, cube roots, and other irrational numbers to a specific decimal place. Okay, so find the approximate value of pi correct to 2 decimal places. Okay, so pi is equal to what? 3.14. Okay, that is equal to 22 by 7. If we try to divide 22, okay, so we are trying to divide 22 by 7, right? So we can't divide this by 7. So what we do is we put 3 here. Okay, so it will be 7 into 3 is equal to what? 21. So we have 2. Then we put a decimal right here and we put a 0. So what will be left with is a 0, right? We can put a 0 right here. Okay, putting a decimal, we can put a 0 right here, so it will be 20. So 7 into 2 is equal to what? 14, right? So we have 6. Okay, so we can put another 0 here, so it will be 7 into 7, 7 into 8, 7 into 8. Okay, so it will be what? So it will be 7 into 8 is equal to what? It will be 56, right? So it will be approximately equal to 3.14. Okay, so up to what? 2 decimal places. So let's see the third kind of question, that is simplifying expressions. So questions requiring candidates to simplify complex mathematical expression using BODMAS rule. Okay, so various algebraic properties. Okay, so simplify the expression, this one. So what is BODMAS rule? So BODMAS rule, right? BODMAS rule. So B goes for brackets. So search for brackets and search for innermost brackets. Okay, so innermost bracket is this. These are the brackets available here. Okay, then we need to simplify them first. So it will be what? 8 into 2 minus 4 is equal to minus 2 plus 6 by 3. So BODMAS, then we go for exponents. Are there any exponents? Since there are no exponents, okay, we avoid this. Then we go for division. So is there any division? Yes, there is a division available. So 8 into minus 2 plus, so this will be 2, right? Because 3 into 2 is equal to 6. So then what we go for is division is done. Then we go for multiplication. Are there any? Yes, there are. So it will be minus 16, right? Plus 2. So then we go for addition. Are there any? Yes, addition. So it will be 2. Then for subtraction, it will be 60. That is equal to minus 14. So minus 14 will be the correct answer. Okay. So let's see the step-by-step solution. So 3 plus 5 into 2 minus 4 plus 6 by 3. First we go for BODMA. Yes. First we go for brackets. So we solve the brackets, right? So then we go for exponents. There are none. And then we go for division. So we solve it the division. Okay. Then what we do is we search for multiplication and we do it. Okay. So multiplication is done right here. And what happens next is we add the numbers and subtract the numbers that are there. So we are left with minus 14. Let's see the fourth kind of question. Okay, that is fraction simplification. So problems involving the reduction of fractions to their simplest form by cancelling common factors. So simplify the fraction 24 by 36. Okay, 24 can be written as what? It can be written as 6 into 4 and 36 can be written as 6 into 6. Okay. So what we can do right now is we can cancel 6 from numerator and denominator. What we are left with is 4 by 6. We can also write 4 as 2 into 2, right? And 6 as 3 into 2. So we can cancel also 2 from both the numerator and denominator. What will be left with us is 2 by 3. So the correct answer will be 2 by 3. We can also write this as 12 into 2, right? Whole by 12 into 3. And cancelling the 12 from numerator and denominator, what we are left with is 2 by 3. Okay. We can also solve it by what method? So 24 is equal to what? 2 square into 3, actually 2 cube into 3 by 2 power what? It will be 2 power 2 into 3 power 2. So cancelling the 2 and 3 in the numerator and denominator. Okay, what will be left with us is 2 by 3. Okay, so in all the three kind of methods we are arriving at the same conclusion. Okay, so 2 by 3 is the correct answer. So let's see the step-by-step solution. So the greatest common divisor of GCD of 24 and 36 is what? 12. So divide both the numbers of numerator and denominator by 12. So 24 by 12 is equal to 2 and 36 by 3 is equal to 36 by 12 is equal to 3. Okay, so percentage approximation. Okay, so questions where candidates need to find approximate percentages of numbers without using a calculator. So without using a calculator, find 15% of 80, right? So this implies that 15 by 100 into 80. So cancelling a 0, what we are left with is 15 into 8 by 10, right? So cancelling with 5, what we are left with is 3 and 2. So this will be 3 into 8 is equal to 24 by 2 is equal to 12. So 12 is the correct answer. Okay, so 15% of 80 is equal to, in the step-by-step solution, 15 by 100 into 80, so to 0.15 into 80, that is actually equal to what? 25. Okay, so let's see the type of questions. That is sixth kind of question, that is on approximate calculations. Okay, so problems requiring candidates to perform approximate calculations involving addition, subtraction, multiplication and division. Okay, so calculate 15 power 1 by 2 minus 2 approximately. We already know that 15 root over is approximately equal to what? Root over of 16, because if we write 15, then 14, 13, 12, 11, 10, 9, so this is the perfect square just before 15, and just after 15 what we have is 16, that is a perfect square, but their difference is what? Only 1, and their difference is 1, 2, 3, 4, 5, 6. Okay, 7. The difference is 7. So the shortest will be 16. So it is approximately equal to 16. So it will be 4 minus 2 is equal to 2. So root over of 15 minus 2 is actually approximately equal to 4 minus 2 is equal to, right? So let's see. So this is approximately equal to what? 16 root over of 16 minus 2 whole is equal to 2. So this is the correct answer here. So let's see the seventh kind of question. Okay, that is on simplification of equations. So simplify algebraic equations and expressions to find the value of a variable. Okay, so solve for x in the equation 2x plus 5 is equal to 17. So this implies that 2x is equal to 17 minus 5, that is equal to 12. So this implies that x is equal to 12 by 2 is equal to 6. So 6 will be the correct answer here. Okay, if we solve for x, and since this is a linear equation, so the only solution to x will be 1. Okay, that's value is actually 6. So let's see the step-by-step solution. So subtract 5 from both the sides to isolate 2x. Okay, so what we do is we subtract minus here and minus 5 here. So what will be left with us? 2x is equal to 17 minus 5. Okay, so this is equal to 12. Therefore, like that x is equal to 6. Okay, so as you can see here, 2x is equal to 12, dividing both the sides, okay, by 2 to solve for x. So 12 by 2 is equal to 6. So let's see the eighth kind of question, that is squaring and cubing. So problems involving the simplification of square and cube expressions to obtain the final result. So simplify the expression 4x square. Okay, so 4x square is equal to what? 4 square into x square, that is equal to 16x square. So it is the expression here. So bracket 1 is, the bracket is missing actually. Okay, so we can write 4x into 4x, that is equal to 4 square into x square. Okay, so the bracket is missing here, so there is a simple typo. So this will be equal to 16x square. So let's see the type of question 9. Okay, so the conversion approximation is what? So problems requiring candidates to approximate measurements when converting between different units. Okay, so convert 25 miles to kilometers approximately. Okay, when the conversion factor as 1 mile is equal to 1.6, so 25 mile is equal to this much into 1.6. So this will be equal to 25 into 16 by 10, right? So solving it 5 by 2, so it will be what? 8. So 5 into 8 is equal to 40. So this will be 40 kilometers. Okay, so 25 miles is equal to 25 into 1.6 kilometers, that will be 40 kilometers. Okay, so what we have learned in this lecture is we have learned the basic concepts and some types of problems. Okay, so the basic concepts were some what is approximation and some type of approximation. So rounding of numbers, okay, that was the first property, and estimation was the second property, decimal approximation was the third property, and rounding of numbers we learned what it was. Okay, we learned what estimation was, we learned what decimal approximation was, we also learned what simplification was. Okay, so it is what? Mathematical operations to get more efficient and understandable. Okay, we learned some properties of simplification, that is order of operations, simplifying fractions, exponent rules, square and cube of numbers, and how many square and cube numbers do we need to remember. So we have also learned what is order of operations, simplifying fractions, exponent rules. So these were the 3 important exponent rules, and we verified them by taking some examples. Okay, we also learned that the order of operations can be done via using the Bodmas rule that we already know. So in the fourth kind of property, we learned what square and cube of numbers are, and we also learned that remembering up to 20 number is actually very good idea. And we also learned all the type of questions, that is rounding off and estimation, decimal approximation, simplifying and expressions, fraction simplification, percentage approximation, approximate calculations, simplification of equations, squaring and cubing, and conversion and approximation. Okay, so from this topic what you can expect in exam is there must be questions, but they will be mostly in different topics. Okay, but the concepts you learn here will be vastly used in those topics. Okay, so what you need to learn, you need to learn all kind of properties of approximation and simplification, so that you could use them when you are in need. Okay, and these kind of techniques will actually help you out, because in exam what you will have is, you will have a question on concept A. Okay, then what will happen is, in order to arrive at answer B, what you need to do is, you need to apply some techniques using approximation or simplification, then you will arrive at answer B. Okay, so that's enough for today. Thank you.